and all. Whereas, some other aspects like I'll be allocating some topics to you. I'll ask you at the end of the session who are all interested. Okay, so just members can share the names to allocate the topics to present in the session. Okay, so just daily 10 to 15 minutes. Three members. Okay, like first topic is guys Spark architecture explanation. Second aspect is guys like Hadoop and Spark integration and benefits. Third aspect guys RTD usage and importance. Fourth aspect is RDD create and access along with transformations. Fifth is RDD actions, which are all the actions we're having. This is sixth because 6 members you can give the names today, guys, and this is without replacement. That means once Surendra has given name, he cannot give for the other session. Okay, like that. So definitely all the members should present. Okay, that is the only the simple thing, guys. So as to extract your way of explanation and all these kind of thing. Okay, right. Today actions and finally in the today's session we discussed about partitions and partitions along with the repartition and coalesce property. Okay, so these things, guys, 6 members, at least for tomorrow, 3 members are required, or else we can start from the day after tomorrow also. Don't worry, we can start either. No hurry. Only the thing is efficiency is important so that I can mentor you. Okay, rather than training. Okay, this is the way you need to explain and how we are collecting the data and how we are exhibiting your findings. Is a kind of learning, guys, nothing else. So that in a way, some repetition happens. At the same time, I can also give you with my experience, like, I want to utilize my experience to empower you rather than train you. Okay, so this is a holistic development kind of thing. So just your support and cooperation is definitely required. Without you people, we cannot move ahead. Okay, just to share the names before the end of the session so that we can uh, preferably, just along with the topic also you can give so that we can have, or else roughly if you are giving name also, I can assign the topics, whichever the way you can opt, we'll go ahead with that. It's a dynamic kind of thing. There is no kind of mapping or something. Only the thing is just you give the names or I'll allocate the topics, or else out of these 6 topics, whichever the topics you are interested, you can hand over the topic. Okay, right. Now we are good to go, guys. Just we are moving ahead with respect to um, the corresponding RTDs. Okay, whatever the RTD we have discussed. Now let me show you some kind of the convention by sharing the screen, which is nothing but RTD. The RTD repartition as well as the coalesce. Before break, just we have seen that there are certain aspects where partition can take place, and partition is one of the important aspect in the optimizations of the Spark. Spark follows the specification of the Hadoop. How Hadoop, just it is having some block size. Based on the block size, Hadoop is going to perform some sort of the activities. Now we are having RDD with us. RDD dot get number of partitions. Just we are having RDD. If you remember, we have not given any partitions. Just Spark itself allocated the partitions for the Yahoo stocks. Now the point is, guys, just we are having some sort of this notion also along with the partition kind of thing. I can able to verify RTD dot. So just we are having this support of the functionality so as to cleanly or keenly observe the appropriate records available. So this is how we are seeing that. Now there are certain options, guys. I need heavily your support. What I'm doing here is, guys, this RDD I am repartitioning in such a way that, okay, in such a way that just whatever the RTD I'm having, just I'm applying the repartition because I don't want to end up with two partitions. Rather, I want to leverage to five partitions. Okay, so repartition of five. Now, if you are making use of RTD underscore RE got get number of partitions, obviously it will be giving us some five. Okay, I'm having the five partitions. Yes, you're right. Now I'm going to talk about this thing also, how these particular things are distributed, because manually we are not doing anything, guys. Just we are specifying our consent. These many partitions I need. Then obviously your Spark is distributing. So in the earlier thing, we are having 605 and 580 and 589 records in the two partitions. Now we are having five partitions. We felt that rather than going with the two partitions, it is always better to go with the five partitions. Maybe we felt that at that moment in the discussion. So still, there is not imbalance or abnormal kind of thing. In fact, partition 1, partition 4 and partition 5 are nicely span over with 240, 240 and 240. And remaining two partitions very near 244 and 230. Like with 4 and 7 10 distinction. Okay, this is 6 distinction. So more or less it is keeping the momentum of the corresponding record. That's how the Spark is performing the activity of partitioning the data. Now one more thing is once we get into this particular repartition, one thing is clear. Just we could able to leverage this particular repartition, or else what I'm doing here is again RTD RE1 equal to just what I'm assigning. So just if you are making convention of, I'm having this RTD with me dot repartition of, just I'm increasing the partition number into 10. Okay, I feel that okay, maybe 5 rather than 5, I can able to go with 10 also. Now RTD RE1 dot just I am making use of get number of partitions. Okay, 10. And similarly, just I'm getting this distribution also, which is a easy way of getting this particular distribution. Collect. Now automatically how those 5 records got distributed, these 10 records also getting distributed. So one thing we observed, either I can reduce or increase the number of partitions. Now let us have a look on what exactly this documentation of the repartition. So RTD repartition, return a new RTD that has exactly num partitions, those many number of partitions. However, we have seen 5, we have seen 10 like that. Can increase or decrease the level of parallelism in this RTD. Internally, this use a shuffle, most important point, guys. This use a shuffle to redistribute the data. To redistribute the data. If you are decreasing the number of partitions, I am holding this point. Okay, now one thing is repartition helps us so as to increase or decrease the number of partitions. Keep one point in mind that we are making use of some kind of the shuffle also. We are in the sense internally Spark is maintaining that particular shuffle so as to handle the repartition. But with the repartition, you can able to perform the appropriate logic like in such a way that either increase or decrease. Now we are having RTD RE1 with us. and I am getting this number of partitions also. Obviously it is 10. Just now we leveraged. Now what we are doing here is guys, just observe here. I am making use of reassignment. I don't want to create the new RDD every time. This time what I'm doing here is just I'm reassigning this particular thing with the help of the coalesce property. Now 10 is there now. I don't want to keep 10, whereas I want to give 4 partitions. Okay, rather than 10, I felt that okay, with the team discussion and all, we want to reduce that into the 4. And then what I'm doing here, just I'm now getting this number of partitions. Get number of partitions. Obviously, it should be 4. Okay, 4 I got. That is fine. Now the distribution also we are pretty much interested now how balanced it is. Just I can make use of this convention and just I am collecting the data. Okay, so just I am getting the span over. So 4 partitions, there is a little change guys actually, because this point I want to clear. Like if you are using the coalesce observation and I'm having this one more thing actually, where is the tree partition? Earlier I'm having RDD, RE. Okay, so that is a repartition. What I'm doing here is again I am publishing the results of these things guys. Okay, I need your support here just to analyze the data, what we are doing and all. Okay, so just have a look on this. This is the span over of the coalesce, and this is the span of the partitions with respect to repartition. Okay, now I'm pasting in the chat window. Okay, so that have a look on these two aspects and come up with your analogy. That is one thread. That is one thread. Now this is one thread. Next important thing is guys, just to think through how the equivalence okay is happening, or else I'll do coalesce is 4 now. Repartition also should be 4. So what you can do is we can add this thing RDD RE. Just I am assigning RE dot just repartition so that you can also have some observation on the equal basis. 4. Now I am inserting this thing RDD repartition. This thing, and then we are making use of map length of the partition and collect. Observe here. So 4 partitions, 300, 304, 300, 290. Same I am getting here. Let me paste after this this thing, and let me run this guys. This is the resultant of the repartition. Repartition with 4 option and coalesce. Let me print that particular coalesce aspect also. This is the coalesce one. So that you can compare easily. 5, 4, y simply just will compare the both. One at a time observation you can give it here. Okay, how the repartition is doing, how the coalesce is doing. This is one observation I want to make. So analyze yourself. Okay, again one more time I am pasting in the chat window. Okay, so that if I'm moving ahead also, you can open this image. You can analyze that. Okay, right. Now, so this is one point I want to get your understanding. Next important thing is just a minute, friends. So the other point is most important because I have not yet introduced you the of course here we are implementing the logic of repartition and coalesce also we have implemented, but conceptually we have not seen the exact distinction. Now let me try to give that coalesce kind of thing. RDD RE1 get number of partitions. Just if you are referencing this thing, it is not a surprise for us 4. Now what I want to do is I want to decrease this number of partitions with coalesce. Okay, the decrease is of course as usual. Now I want to increase from 4 to 10. Okay, 4 to 10. Now what I'm doing here is guys, RE1. Okay, just I want to reassign this partition. I want to apply the coalesce. What I want to do guys, here I rather than 4, I want to give 10. Okay, increasing. I am trying to increase the partition size. Now, if you are increasing, it is not saying anything. Now, out of curiosity, just I want to check the number of partitions. Now, see, guys, it is a bigger surprise for us actually, because a coalesce here, what we have done is just to, rather than following the 10 partitions, we want to get that particular into 4, because earlier we are having the partitions as 10. Now we can able to get that as 4. That is one convention. Second important thing is now we are trying to increase the number of partitions here. Okay, we tried that to increase the number of partitions as 10. But see, though we are increasing the number of partitions, but still it is sticking with 4. So two important things you need to clarify me: repartition versus coalesce in terms of data distribution in the partition. Second point is coalesce. Okay, so coalesce in terms of increasing the partitions, because if I am trying to increase that particular partition, it has not shown up. Whatever the partition we're having, the same kind of the partition we are the older number of partitions we are getting. Now there is a analogy. Na? Every time there is analogy. Now we got some question from in the Databricks exam also, guys. Uh, I'll reveal that. First, let me introduce this thing actually. RDD RE1, the same RDD I want to use. Now one more option I'm having, coalesce. Just let us see this documentation, guys. Returns a new RDD that is reduced into number of partitions. So by default, if you are considering the coalesce, one of the important notion is it is for the reduction of the number of partitions. It is for the reduction of the number of partitions. Whereas if you are talking about the repartition can be used for either insert or I mean either to increase or decrease the number of partitions. You may ask this question. Then why we need two functionalities to perform the reduction? Because we can happily making use of the repartition, and then we can perform the activity of the reducing or increasing. And in a way, we need not remember two functionalities. One is repartition and another is the coalesce. That is the first point. Second important thing is you can claim that just I'm opening the avenues, guys, multiple thought process. Second point is if I'm having the coalesce, of course, coalesce is not allowing me to increase the number of partitions, because it is I realized that I'm having 10 partitions and I can able to get that into 4. But at the moment I'm trying to increase those four properties or partitions into 10 or something. It has not turned up. Okay, so still 4 partitions after giving the instructions. No problem, guys. Don't worry. Just what we'll do is in this kind of the things, latest we're having 4 partitions, but your coalesce is not turned up. Even I'm insisting on giving the 10 partitions. No problem. What we'll do is just we are giving 10 and there is a option called shuffle. By default, it is true. By default, it is false. Now I am giving true. Now what I'm doing here is guys, RE1. Now you get the number of partitions. Then obviously, yes, you're right. 10. See, it is taking little more time. Okay, so because in the earlier kind of thing, okay, just if you are observing get number of partitions, now it is becoming 10. So what I mean to say here is by default your coalesce, okay, in coalesce shuffle is false. Shuffle is false. Whereas in your repartition, here only I am writing in your repartition by default shuffle is true. Now what we have done guys here, just we have managed, we have taken the other way around and we insisted coalesce to shuffle. So obviously we can able to observe that value as 10. Now friends, just I'm opening the chart. Please clarify these 2 points. Excellent, Surendra. Very good. Very good. Okay, already you guys are rocking. Definitely, that is the extra mile travel. Always you will be getting rewards for that in terms of certifications or in terms of your happiness through knowledge. Okay, almost you guys have given the answer, but let me put in this way. A repartition. Okay, repartition can increase or decrease. Okay, the partition. Okay, this is the first point I want to clarify with you. What is your analogy on that? Second point, guys, related to the repartition. Repartition shuffle the data. Now the problem is, guys, what is the issue with the shuffling, guys? Yes, you are right, Kannan. I love that. I like it because see, that is the point, Kannan. Actually, you are very clear and you are getting the insight actually. Excellent. This is the mindset required for the sake of clearance of the certification or raising the bar. Yes, I'll come back to that. Okay. Now the other point is coalesce decrease. Yes, you're right. And I request you all guys to have a look on the Kannan's message. It's perfectly is a curated kind of thing I can say. And one more important point is in terms of repartition, we have taken two things. Repartition can increase or decrease the partition. Repartition shuffle the data. Whereas the third aspect, if I am taking the coalesce property, coalesce basically decrease the partitions without shuffle. Friends, be cautious. Be cautious. Whenever you are using the coalesce, your mindset should be okay. Coalesce I should use for the decreasing of the partition. That's all. But we are programmers now. We are developers. Definitely, we are having the mindset. What happened if I am doing the increase of the partition? I'll come to that. Through coalesce. Okay, let me put in this way. Through coalesce, if you want to, okay, increase the partition, then make shuffle property as true. That's all. Make shuffle property as true. So this is the way how we are making use of the convention, you guys, like while working with the repartition and as well as the coalesce mechanisms. Okay, so now the way we need to observe this thing is, as our Kannan said, coalesce can be used for both increasing or decreasing of the partitions. But by default, okay, technically Coalesce is best because one thing guys here, Spark, understanding and optimizations are okay, but in Spark you can change the properties also. Like, suppose if I am saying something no, and tomorrow you may come to me, hey, Dr. Umar, just I have gone through this website or blog. They said that we can modify that. Yes, that possibility is there, guys. That's what I'm saying. Whereas in other kind of the programming languages or environments, they are pretty stringent in the norms. But whereas the Spark developers are very, you know, there are so many loose ends actually. So, like, I'm not saying it is not perfect. Of course, it is for the flexibility of the programmer, guys. So at the coalesce specifically, if you love and if you want to use that coalesce, of course you can. Provided if it is the decrease of the number of partitions, then you can straight away go ahead with the coalesce property. But still, some curious programmers, they want to maintain the convention of managing the coalesce property to increase the partition. Yes, you can do that, provided you can have a look on my fourth option, that is coalesce. Uh, yeah, whatever the coalesce property we're having, just I can mention the shuffle. So as Mayur said, exactly. Okay, coalesce involves less shuffling or no shuffling, friends. Actually, it's not having any shuffling. Otherwise, if you want to explicitly mention the shuffle, then only we are going to get the increase of the partition through the coalesce. Okay, make sure of that. Let me spend some time from morning onward. Just I'm skipping the comments made by you. Just in the chronological, I will be going. So Shahrukh says repartition increase the number of partitions, whereas coalesce decrease. Perfect. And then, however, Kannan has given, but in coalesce shuffle is not completely false, right? Exactly. Minimal amount of the shuffle occurs. Minimal amount of the shuffle in the sense, in terms of increase only, it is going to get the shuffle. That is the reason I have given one image here, guys. If you come across this image, actually in the repartition, we are having a nice balance of the data. If you observe, if you click on the second image I have shared, 300, 304, 300, 290. More or less, hardly we are having 4 difference or 10 difference. But in coalesce, guys, just we are having 245 at one partition, 350, almost 100 plus differentiation. Again, we are having 240. Again, we are having 360. Two partitions are 4 difference. Two partitions are 10 different. So what I mean to say here, guys, in case of the repartition, there is some advancement or advantage, balancing of the data, because because the main important aspect is, guys, just whatever the partition we are planning or managing, repartition is however increasing or decreasing. But whereas coalesce, though it is decreasing, now I need to ask someone. So definitely, what is the observation from this? Maybe Kannan can try, or Mayur, or whoever, maybe Vedant and Surendra. So because the way we are seeing this particular outcome is bit distinct, guys, compared with the other options. So now the point is, one thing is pretty clear: repartition, you just shuffle either to increase or decrease the number of partitions. Coalesce, definitely for the sake of the decrease of the partition without any shuffle. That is the advantage, guys. Actually, we are on the edge of advantage of optimization, whereas the other way around, coalesce can be used for increasing of the partitions, provided if you are okay to shuffle the corresponding number of to shuffle the operations. Because what is the problem with shuffle, guys? What is the issue with shuffle? What is the issue with shuffle?
What wide transformation?
Mayur, excellent. Wide transformation. One more problem is shuffle uses many communications and it kills our cluster. Actually, it kills our cluster. And first point is absolute, Mayur, because
Network
communication,
IO.
network IO, Nisha, perfect. Because the transmission of the data, every time I am messaging and I'm getting back, and it's more or less disk IO in Hadoop, because we are going into the same a revolutionary approach, because Hadoop, we left with we left that Hadoop because of this batch processing disk IO. Again, we are moving back to that convention. Of course, not wrong. That is not wrong, because the main purpose of our Spark is to attract the optimization technique. That is the first point. Second important thing is, friends, uh, by default, it is providing some design principles. Coalesce meant for decrease. Okay, as our Sahu said. And moreover, repartition you can use for the either increase or decrease, provided shuffle is by default, friends. In repartition, we cannot avoid the shuffle, but coalesce intentionally, because you are on the edge. You are on the edge. That means, suppose as a developer, you can decide that whether I can use the coalesce or repartition. Suppose your team decided to increase the number of partitions, without any thought process, go with the repartition. At least we'll be getting the balance of the data. Whereas if you are shuffling, if you are applying the coalesce, obviously there is an imbalance, definitely, because of the coalesce imbalance nature. And however, you are incurring shuffle on that. Okay, why you are on that side? Just you can make use of the convention of performing the activity. Now, before concluding this particular session, what I'm doing here is, guys, let me pick up how these particular repartition and coalesce are really performing. Because just like that, we are not happy with the way we are observing this aspect. Rather, with the simple diagram, I want to show you how a repartition happens. Okay, and how a kind of how we are getting the coalesce happen, because that definitely gives you the clarity about what I am talking, and why we need to select coalesce property while making use of the decrease of the corresponding spark partitions. Okay, have a look on this, guys. Pretty simple diagrams, and which are very much easy also. Coming to the first diagram, which I am trying to demonstrate on some certain aspects related to partitions. 5 partitions are there. I am making use of a repartitioning approach, where maybe the increase or decrease, just what we are doing is many observations or many shufflings are going on, because to balance the data, 110, 100, 110, like that, because there is a perfect balance of the data, perfect utilization of the partitions. Of course, that is the strength of this repartition. So there is a partition 1 involves in all these 2 outcomes, partition 2 also, because the shuffle operation itself says that whatever the partition I am having, it is participating in all the outcomes. There is a mesh topology kind of thing. Whereas if I am talking about the coalesce property, there is no shuffling, guys. You may ask me, without shuffling, how come the coalesce is performing the decrease? This is the perfect analogy, guys, because it is keeping aside some of the partitions. It is adding the other partitions to that. That is what the reason some may be getting 150, some may be getting 260, like that. Because already existing we are having 100, and it is keeping 50 from one partition. Already we are having 150, it is adding 110 from other partition. Okay, so that is the reason why there is a highly imbalance of number of records in each partition with respect to the coalesce. But that is okay. That is okay. We are not striving for the balancing, na? Because partitions shuffling is more expensive compared with the balancing. Okay, so automatically, if you are considering the repartition as it is having the flexibility of touch basing all the partitions, there is a reasonable amount of shuffling is there, and obviously the all the partitions are getting the balancing nature. Whereas if you are talking about the coalesce kind of aspect, coalesce is something like which is not at all opting for the shuffle operation, because the default property of the coalesce is no shuffle. Default. What is the default nature of the coalesce? Default nature of the coalesce is to decrease the number of partitions. To decrease the number of partitions. If at all you want to perform increase of the number of partitions, maybe in a different way, if you are thinking, yes, friends, coalesce definitely allows us so as to perform the activity of increasing the number of partitions, provided you need to opt for the shuffle equal to true. Basically, in the understanding of the coalesce, our shuffle property is false. Our shuffle property is false. Whereas in the repartition, of course, our shuffle you need not explicitly mention, but it is true. Okay, the question is like that, friends, in the Databricks exam. If I want to decrease the partition, okay, if I want to decrease the partition and I am giving the shuffle equal to true, then what is the outcome? Okay, now the options will be like shuffle is by default false. You need not maintain shuffle as true in the decreasing. Shuffle is by default true for the coalesce. Yes, you can do like that. All the similar kind of the options will be getting. So the question is pretty clear that so you are decreasing and you are making shuffle as true. False, no, that one. The answer itself is the question itself is incorrect. Because if you are making use of the coalesce for the increase of the partition, then we are good to go with the shuffle equal to true. Whereas if we are using the coalesce property so as to decrease the partitions, you need not touch base on the shuffle, guys. Okay, you need not touch base on the shuffle. So these are all the kind of the questions we are getting while implementing the coalesce and as well as the repartition. One more thing, just a second, guys. Just what I'm doing here is I am opening one more presentation. Bear with me. Just what I'm doing here is I am pulling some kind of questionnaire related to our examination. Uh, so just I'm having these questions somewhere. I kept that. Just a minute, guys, because those things are pretty important for us. RDD further and the way we are getting the convention. 1 minute, guys. Optimizations. Architecture. Okay, got it right. So now the question is simple question related to the Spark driver. Let me paste this particular question here. The OneNote. Hope I am sharing the screen, or else let me share once more. Yes. Okay. See, guys, here the way how we are getting the questions in the examination. Which of the following statement about the Spark driver is incorrect? Incorrect. Okay. Not correct, friends. Incorrect. The Spark driver is the node in which the Spark application's main method runs to coordinate the Spark application. Driver, of course, main function. Somewhat reasonable. Second thing, the Spark driver is horizontally scaled to increase overall processing throughput. We are having some doubt, friends, because Spark driver is only starting and ending of the code because main function. We're having the doubt. Okay, we kept aside this answer. Next one is Spark driver contains the Spark context. No matter, guys, whether there is a Spark context or Spark session, both are correct because Spark driver may be driven by either Spark context or Spark session. This is correct only. First one also nearby correct. Second, we're having some doubt. Keep aside. Maybe some other option we have to get from the other D and E. The Spark driver is responsible for scheduling the execution of the data by various worker nodes in cluster mount. So here cluster manager is there. One side you are having Spark driver. Another side we're having the executors or worker nodes. Initially interact with the cluster manager and directly executors can communicate with the Spark driver. The sense is like that. We can agree that, guys, because there is no I mean ambiguity in that. Final thing, the Spark driver should be as close as possible to worker node for optimal performance. How many of you agree this locality of the principle, guys? Principle of locality, memory locality. Maybe the members who are having the background of databases and there we are having some convention. RAID architecture is there, guys. Maybe the distributed guys also would be knowing redundant array of inexpensive disk space. Suppose and I need not go to that much also. If you consider the differentiation between RAM and cache memory, RAM and as well as the cache memory, which is fastest, friends? Whether RAM, cache, or hard disk? Which is fast? Obviously, cache
Cache.
memory.
Cache.
Cache memory. Yeah. Why cache memory is very near, guys? What is the reason behind that? Can someone help me? Yeah, you are all right. Cache memory is faster because for our active set, cache is near compared with the random access memory. Reason is like this. So most frequently accessed items are kept in the cache memory. Logically, that is the thing. But if I'm talking about the cache and RAM distinction in a more layman kind of the language, cache is nearest to the appropriate active set, and RAM is next to the cache. Like, as that cache is containing the repeated information or frequently accessed information. Now the point is simple, guys. Like, whatever the functionality we are using in terms of this thing also, it is always preferable to maintain the executors and as well as the appropriate exhibitors. Spark driver, if it is near to that convention, yes, of course, it can be near to that option. And whereas if you are making use of the convention, how I am getting this data and how fast the information is. So obviously, guys, here there is nothing wrong in the last statement also. Okay, so if you are observing the B, actually Spark driver is not related to the scaling, friends. Actually, scaling is something related to our executors. Scaling is something related to our slots, which is related to the worker nodes. Okay, so obviously, without any doubt, yes, the answer is this one. The Spark driver is horizontally scaled to increase overall processing throughput. Spark driver is not having that responsibility because starting itself, I said incorrect statement. This is the way how you need to perform the questionnaire and you have to prepare, guys. Okay, definitely I'll give all the possible ways how we are preparing and how to answer these kind of the things. But only the thing is you strengthen your basics. You strengthen your confidence levels, observe the architectural aspects, okay, and practice coding, whatever the code we are referring and whatever the code we are trying to support the learning. So just immediately after completion of the session, take your time just before 24 or 48 hours, just to complete the revision process also, so that proudly you can crack that examination. And not only examination, guys, you can get the consolidation of your learning also. Okay, so meantime, just let me ask this thing. Have I got any updates? Okay, if you are not giving, I will give, no problem. I am not having any restriction on that. First, I will take Akhil. Akhil, what is the first topic? Just to refer to that topic, Akhil will be given topic 1, and thereafter Nisha, I'll give topic 2, and thereafter Shanmuga, I'll give topic 3. Randomly, I'm giving, friends. And Mayur also, I can see star performer topic. Okay, 3 members are enough now. So initially, and I'll okay, no problem. I'll announce, let announce Mayur topic 4, and thereafter Vedant. Vedant will play. You can realize that definitely. I can. You can also have the look. Vedant topic 5, and then Elias. Elias topic 6. Topic 6. Okay, so I'm not asking you to give tomorrow, guys. You can give first three members can be you can give day after tomorrow. Okay, so just I'm assigning, I mapped the topics also up to, okay, first three members can give the presentation, can give on tomorrow, Tuesday, na Wednesday, and then okay, 3 members can give on day after. So this thing 4, 5, 6 can give on Thursday. Okay, that's it. So guidelines and all simple guys. Okay, just you prepare 5 to 10 minutes and accordingly you either you go with the document or presentation, but just to prepare. Okay, Mayur, why you are not available? It's not optional, guys. Okay, so I'll be simple only, but straightforward and stringent. Okay, so don't say all those things. Okay, don't say all those things. If you are not available, again I'll okay. So you take time, guys. That is what I'm saying. As a part of your empowerment, you need not say no or I'm not talking about Mayur actually. It is all for all the cases. Maybe later point of time you can come back and say that, and I'll make the alternate arrangement. No problem. I'm having plenty of options. But in the meetings also upfront you these are all the practices I am giving you actually indirectly as from leadership kind of thing. Indirectly, I'm training you not only in PySpark, in all the other aspects. I'll actually look after the ambiguity. Now I got the message actually, and that message also in the team. Direct 35 members around are there. I got I'm not available on Thursday and Friday. Nothing is there. Nothing Dr. Uma or Sir or nothing is there. Just he is putting the message. So just don't do these things, guys. Avoid that thing. Okay, avoid that thing. Why I'm saying is maybe you can personally chat with me. I'm talking about the meetings and all these things. Just personally chat with me. And before completion of the meeting, this is fine, guys. This is in between us only, na? Just I'm taking the liberty. Don't worry. You're all my friends, nothing else. But in the meetings also, whenever someone has assigned some work or some task to you, don't say that I'm not available. I'm not aware of that. Don't say that immediately. Just you work through, think through. Can I have some other alternative? Personally, you go and meet that, or else personally you go and message that guy, because it definitely gives you some kind of weightage. Upfront, if you are saying means people feel that okay, this guy is having something, and why he is not accepting? Why simply creating negative tendency? Okay, so just you think through. Okay, take your time. No problem. This is all in between us only. Na? I can reshuffle and manage the things. I'll follow the repartition here. I don't follow the coalesce or something. Okay, I'll reassign the things with the help of the shuffling and all. But my sincere advice and suggestion as a well-wisher is try to avoid all these practices. It will keep you high, and don't highlight in the entire group. Okay, so no problem. It's perfectly all right. Maybe he's having some emergency or something. Our reasons are always valid, guys. But how we are conveying, how we are making use of that, I mean, launch pad, how we are conveying the information. Okay, that is the most important way. Information might be correct or you are genuine or whichever, but don't reveal immediate responses. Okay, just purely you are absolutely you might have applied the leave long back, maybe planned leave or something. Perfectly all right. Okay, but my suggestion would be just to try to avoid immediate replies or something, especially in the major projects and all these discussions. Clients might be there. Okay, or else maybe leadership would be there who are keenly observing us. Okay, so that is what my sincere suggestion to all my friends. I need your success. I want to see your success. I'll be with you. Okay, in all the data science, machine learning genres, everywhere, not only this thing. Okay, so we'll have the nice research and all these kind of the things definitely. But in the meantime also I'll be giving you some sort of suggestions. Don't take negative. I am very close to you and like your well wisher and friend. Okay, thank you guys. With this, just we can end up our session. I have little overboarded you, but it's unavoidable. So due to the demand of the subject, so all the best, guys. Just to prepare well, except Mayur, and let me get some other content. or else I'll replace Mayur with some other. Okay, before end of the day. Uh, okay, meantime, let me get if any members are interested to what exactly the Mayur's topic, just we'll research on that and we'll make use of the convention. Okay, that's all, guys. Thank you. Mayur's topic is 4. And if anyone want to take that fourth topic, you are welcome, guys. The fourth topic is actually RDD create and access along with the transformations. Some of the transformations you can scope and explain, right? Okay. So thank you, guys. If you are having any doubts, please let me know. Otherwise, let me 1 or 2 minutes I'll take to complete the key takeaways of the session. Uh, so let me share this convention, guys. 1 minute. I wrongly shared the thing. Maybe this one. Yes. Okay. So the key takeaways today's session, 3 hours, very 1 hour like that I felt. So key takeaways. The very first point, what we have started, guys, actually, data partitioning, right? This thing we have seen. Second thing we discussed, map reduce. Third thing we have discussed, combiner. And fourth option, we have seen some repartition. And fifth one, coalesce. And extensively the shuffle operation. And along with as a part of the okay, I need to evaluate now data evaluation. I allocated 6 topics to 6 members. We are starting from Wednesday. Just we need to prepare those topics and all. It maybe just I'll be spanning all these kind of the things. Every member should give this kind of the convention. Okay, as a part of the individual assessment. It reaches to your managers and whoever. Okay. So, right. Thank you, guys. Thank you very much. So see you back. And in the tomorrow session, what I'm trying to complete is next session. I'll talk about the broadcast. Broadcast one more time we'll discuss, but here as that is RDD relevant, we can accumulator and then the favorite aspect, friend, data frames API. This we are going to introduce. Very, very easy. It's not like important means it's not tough. Definitely. It's very easy and accessible compared with RDD. Data frame is more flexible. That's what they call this data frame as the high level API. Thank you. Thank you, guys. Thank you very much. See you back in the tomorrow's session. Okay. All the best. Bye.